Now let's talk about those scenarios. So which one do you want to do? I think I want to do the added one first, and then we can talk about the subtracted one. So pick one where mass is added. Which one do you want to do? Raindrops or snowballs?
Snowball.
Okay. Actually, snowball will be in 2D.
Yeah.
So let's just do 1D first. So let's say we have a raindrop, and it is picking up more and more suspended particles as it comes down. So these are my suspended particles. As it comes down, it is picking up more and more of these. So the final would be, say, this one with this added onto it. So let's say in this time, it just picks up one. That might be easier. So if the initial velocity of this mass, big mass, can I call this M? And this little mass, can I call this delta M? And suppose this big mass is moving with the velocity V, and this little mass is moving with the velocity U, and they're all a function of time. Then may I write at the final instant M plus delta M for its mass? And may I also write V plus delta V for its velocity? So some other velocity, right? It picked up one magically out of the suspended, and that's what we have. So in order to solve for this, I know, okay, force was what? dP over dt, and that's what I'm looking for. So keep this in mind. This is what we're looking for, right? We're looking for F. May I write delta P as P total at time t plus delta t minus P total at time t. So imagine this is at time t, and this is at some future time t plus delta t. This would be M plus delta M and V plus delta V. Yes? What is momentum? M times V. And will this be MV plus delta MU? This is delta P, and that will give me P, right? This is just MV, and this is delta M, delta MU. Okay, may I open this now and have MV plus M delta V plus delta MV plus delta M delta V minus MV minus delta MU. So far, so good? Okay, may I combine a few things? So for example, I have a delta M here and a delta M here. May I combine those two? And then I have a delta V and delta V here and here. May I combine these two? So am I allowed to write, zoom in, these two get canceled, M plus delta M plus delta M minus U. Okay, so may I write one very important thing. What is this? The relative velocity of the big mass to the velocity of the tiny mass. Okay? So if this is going with the velocity v and this is going with the velocity u, the relative velocities of them can be written as VR. So I can rewrite this as m plus delta m, delta v, plus delta m, VR. And that was delta p. May I divide all through by delta t? Delta t, delta t, delta t. Am I allowed to do that?
Yes.
Okay. Can I also do a limit? Can I also do a limit when delta t is very small? So in that case, may I ignore delta m with respect to m? I have a big car and the fuel loss is very tiny in a very short interval of time. May I ignore dm with respect to m? So will I be able to write this as dp over dt? When t is very tiny, does the delta become d? So this means may I write this as m dv over dt plus dm over dt vr? Where vr is the relative velocity. Velocities of the two masses. So far, so good? What were we looking for? That. So what's on the left-hand side? Is this the external force that's acting on the object? Whatever that external force may be. So the external force could be gravity pulling it down. It could be drag that's acting on it. It could be anything. Any external force that's acting that directly causes the changes in these two things. Good?